Well, hi there. Today we're going to talk about Lesson 38. And Lesson 38 has a lot to do about interpreting graphs. Graphs are visual representations of data. Most times you see graphs in magazines and newspapers. You see them in your textbooks. But if you would go through any standard newspaper, you would see tons of them. Majority of the graphs you're going to see in a newspaper are probably going to be pictographs, bar graphs, or line graphs, because those are the type of graphs that most people know how to interpret. It's easier for them to understand them. Quantitative information is data that's in the form of numbers, and that's why we need graphs, because if somebody just spewed out a whole bunch of numbers at us, we wouldn't really have any idea as to how to interpret them compared to what. So that's why a graph is helpful in that area. Graphs help us to display information that's quantitative so that it makes sense to us. There are different types of graphs. There are pictographs, and as would make sense, pictographs generally use pictures of some sort. If you're talking about types of cars, you might have little pictures of the different emblems of cars. If you're talking about selling tires, you might have little tires. Generally they use pictures. If you're talking about selling houses, they might have little houses, and that might be their little picture. And like for every house, every 10 houses sold might be like one little house picture. Okay, they are an approximation, typically, pictographs are, because you can't really isolate one specific house or one specific car or one specific building or one specific thing. I call them dump graphs because they dump all the data into pictures. Most graphs have these rules. They all must have titles. They all need to be able to be easily seen so that you'll be able to tell which one's greater or lesser than the other. The next kind of graph is a bar graph, and it's like a pictograph in the sense that it is a dump graph. You dump the information into it, the bar gets higher or the bar stays lower, and it represents data. A bunch of data is dumped into it. Its purpose is to show an approximation. It's not going to be exact. If you're looking for exact graphs, you're going to have to look at line graphs. Okay? So a bar graph uses a bar to represent data, and it tends to show the approximate amount of data that's under what category. Okay? Now, I said just a second ago that if you want exact data, you need to go to a line graph, and that is the case. Line graphs use a scale to show very, very individual data. You can see individual scores. If I were to take the scores on your last 5 math tests or your last 5 quizzes and put them on a line graph, you would be able to see that perhaps you got a 65 on one, and 70, and then an 82, and then 84, and then maybe your last quiz you really got hot and you got a 92. You would be able to see that on a line graph. You cannot see that on a bar graph. It just dumps the data. Okay, this type of symbol right here, it looks kind of like a, looks like that. You gotta make the noise too, you know. This type of symbol on a graph shows a break in the scale. Very helpful if the numbers you're trying to represent don't start at 0. For instance, a bowling, most people will score higher than a 0 on bowling. So maybe if you're going to, in any kind of graph, if you were going to represent bowling scores or average bowling scores, maybe your average bowling scores would start at 80, and so you might go from, this would be 0 and this would be 80, because you wouldn't have any data that would show up on a graph anything below 80. Okay, so this in here, it's really nice to help you to see data. It can shrink a graph. It can also be misleading. It really can, and I'll try to show you that here in just a minute. Okay, be careful about these guys right here because they can be misleading. All right, here is what kind of graph? Yes, that's right. It's a pictograph. All right, and the little sunshine right here is 5 days of above average temperature. So, and here's the title of the graph, days above average temperature. And let's say summer, kind of nice to know when, 2013. Okay? So, you go to June. You have 1, 2, 3, and a half. So that means every sun is 5 days. So that's 5, 10, 15, probably about 18 days, somewhere in there. Remember, approximation. You got 1, 2, 3, 4 full suns, so that's 20 days. You've got 1, 2 and a half, so you've got 10 plus maybe another 2, 3. You've got 13 days of above average temperature in August, and the rest of the days must have been cool. Okay, that's how you can represent things like that, and that's a very, like I said, it's very much an approximation, but it's close enough for us to just glance at it and read it, and that's the whole idea of pictographs. You need to be able to just glance at them and look at them. People who are reading a paper, I'm sorry, they don't really want to take a lot of time to look at the graphs. Okay, this is a bar graph, okay, and let's say we want to keep track of the number of bottle caps collected by some elementary middle school students. Okay, they're raising funds. Every bottle cap is worth so much, and they get so many, then they can raise funds for their classroom or for their school. So if you look at this bar graph very quickly, okay, very quickly, you can see which class picked up the most or collected the most bottle caps, right? It's quick, easy to tell. It's this one, okay? The one that was kind of unmotivated and didn't get quite as many, or maybe just forgot about it, here. But it's easy to see. It's right out there in front of you. You don't really even need to know how many they collected so much as you glance and go, wow, those 7th graders, they're awesome. Because look how many they collected. Of course, I would know that. I teach 7th graders all day long, and I know they're awesome. And over here is your number of caps, and here's your grades. Here's your title of your graph, which I told you you have to have. Okay? Which grade collected? 3 times the amount that the 8th grade collected. Okay, well, let's see. Here's the 8th grade. Which grade collected approximately 3 times the amount? Well, it definitely wasn't the 5th grade. Might have been the 4th grade. I would guess that that might be the 6th grade. They look like they were pretty close to about 3 times the amount. You would have to actually measure it to know for sure. But that'd be my guess. It would be the 6th grade. 4th grade's pretty close, but I think 6th grade. Okay, going on. We're going to look at, I remember I was talking about bowling scores earlier. Okay, here's bowling scores. All right, remember that I talked about how bowling scores a lot of times don't start at 0. So this is a line graph, and this is looking at one person's bowling score card over a period of time, okay? And this is the games, game 1, 2, 3 through 10. And over here, these are the scores, okay? Notice we have the broken line over here. It starts at 150, which means that this person never scored below a 150 in these 10 games, so we didn't need anything below that, okay? So you can tell kind of what the scores are. There's a little dip here in game 5, must have been tired that day. Way up here for game 10. Now, if I was doing this, I would put 300 and then I'd be done. And the reason? Well, you can't score over a 300 in a bowling game. 300 is perfect. So, this is easy to see. The general trend, if there was a trend line, and we're not talking too much about trend lines right now, but if you were to draw a trend line means, in general, is the score going up or is it going down, or can you not tell? Well, if I take this and lay it right here, what do you think? In general, is his score going up or down? If you set up, you're right. It's kind of going up and to the right. He has a few down games, like here and maybe there. But if I take and kind of put this so it's kind of in between all the data, like that, and I draw this red line, okay, That red line is a trend line. It's called a trend line. And it is telling me what the general trend of this data is. And the general trend of this data is going up, which means this person's score is going up, getting better all the time. Important, put that in your notes. Okay, so what was Lance's score for game 7? Look over here at game 7. Looks to me like it's about 200. What was the score of his lowest game? Wow, looks like maybe about 150. What was the overall trend? Was he improving or going down? Well, we already decided, didn't we? That the trend line shows that he is definitely improving. Definitely improving. Okay, now we've looked at pictograph, bar graph, and line graph. There's one kind of graph we haven't really talked about, and I want to take just a couple minutes to talk about it. Okay? It is called a circle graph. Now, a circle graph is the whole thing. Okay? It's like a whole 24 hours, or a whole day at work, or a whole course of study, or you have to consider it a whole. Okay? When you are using a circle graph, you're dividing that circle you're taking that whole circle and you're dividing it into pieces. For instance, if you were to divide your lunch into green vegetables, meat, fruit, and bread, you might say that half of your lunch was meat, and a fourth of it was bread, and another eighth of it was this, and another eighth of it was that. And you could actually take your circle and divide that. And that's what a circle graph really does. Let's say you're representing a day in the life of somebody, and that would be 24 hours. So this whole circle is 24 hours. If Jenny's day is spent this way, she spends 8 hours sleeping, 8 hours at school, 4 hours studying, 2 hours on the phone with her friends, and 2 hours napping. Okay, well, think about it for just a second. What part of a day is 8 hours? Well, if you don't know, take 24 and divide it by 8. And you would find out that it is a third. 3 times 8 is 24. Okay? So a third of her day she spends sleeping. So I am going to, and if I wanted to take the time, I would really be fancy, and I would draw my arcs and all that good stuff so that this was exactly precise, but I'm not doing that because I think you kind of get the idea. Okay? So I'm going to divide the circle into thirds right now. Okay? So this third is sleeping. That's 8 hours. That's a third of her day. Okay? Now, she also spends 8 hours at school, correct? That's what it said. She spent 8 hours at school. So, another 8 hours over here, she's at school. Now, have we taken care of 2/3 of the graph, haven't we? We've only got 1/3 left. And how is it divided? Well, we have 4 hours studying, 2 hours on the phone with her friends, and 2 hours napping. So we have to take that last third, and we're actually going to divide that last third into 4 parts. Well, yeah, well, actually 3 parts. But let's divide it in half first. I'm going to get a different color here, just kind of to make it make a little more sense. Okay? So I'm going to try really hard here to divide this like that. Okay? And then I'm going to take one of those parts and divide it again. So that I took that last third and I divided it into half, and then I divided the halves into half. So we have 4 hours studying. And then we have 2 hours on the phone here, and 2 hours napping here. And we have covered her 24-hour day with a circle graph. That's pretty easy to do. Not too bad. If you want to look down here, you can see how I set it up with fractions. 8 out of 24 is 1/3. 4 out of 24 is 1/6 of her day. 2 out of 24 is 1/12 of her day. So if I were to have divided it, these two are 12ths. This is a 1/6, this is a 1/3, and this is a 1/3. Okay, one more thing I want to look at. These are all different kinds of graphs. The top two are bar graphs. Okay, and there's an interesting thing that happens between these two graphs. You have this graph and this graph. They have exactly the same data in them. Exactly the same. Well, what's different between the two? Well, this one looks pretty standard. I mean, there's a little bit of difference here and a little difference here, but look at this one. It looks to me like this is really small and that's really big. But if you go over here and look at this graph, it isn't so much different. The difference is this right here. Okay? The way this is set up, 2005, which on this graph is at 20, is only here on 20. And so it makes it look like this year, really, really small amount, and suddenly in 2008, it's huge. Like, it looks like it's 4 times as much when it's only like 25 more. You have to be careful with them. The elements that contribute to it is definitely this, and it can be used, people use it in a paper all the time to mislead the public. Look at these two graphs, okay? You have Jasmine's growth from age 10 to 13. You have Jasmine's growth from age 10 to 13. Which one's probably more realistic? More believable? Do you suppose that Jasmine woke up on the day of her 10th birthday and said, "Oh, I'm 50 inches tall"? And then on her 11th birthday, she woke up and overnight she had grown to 54 inches tall. And then overnight, on her 12th birthday, she grew to 58 inches tall. No. It was a process. She grew a little, and she grew a little, and she grew a little, and she grew a little more, and then a little bit, and a little bit. Everybody grows that way. People don't just spring up overnight, although I sometimes wonder about my son, who seems like he's springing up overnight. So, a line graph is much better to use to represent something that's gradual, whereas a graph like this, a bar graph, is again what I said before. It's a dump graph. You can put a whole lot of data in it, but you won't show individual stuff. Thanks for listening. I hope this didn't get too long. Have a great day.